Good morning, Riverside Park! Happy Monday. I hope you're excited for today's lesson. Today we will be doing 7.6a, which is to represent sample spaces for simple and compound events using lists and tree diagrams. So, I know we were having a little bit of trouble last week with probabilities, so today we're going to take it real slow. And we're going to just be listing out the possible outcomes we can get, right? So if we want to know, if we're doing an experiment, we want to know all the options that we have, okay? That way it's easier for us to calculate our odds. So let's go ahead and dive into vocabulary, right? And I want y'all to follow along with me. So please, if you have a paper and pencil, take notes with me. That way you can refer back to this as you do your work. And it's going to help you just be able to understand the concepts a little bit better. All right, so our first vocab word is theoretical probability. And it is a probability that's expected. So this is before, right? My keyword for this for y'all is going to be before we begin our experiment. Right, before we flip our coin, what are the odds or what are our options when we flip our coin? And we can calculate that using the picture I have below, right? So it's the number of favorable or desired outcomes, right? So if I was flipping my coin and I wanted tails, right? That's one option that I want out of the total number of outcomes. So when I flip a coin, there are two options, which is how we get to 1/2, 50%, or a 0.5 probability. All right. So all of these things are how we calculate our probability. And remember, this is our theoretical. So these are what are the odds of something to occur. Then, if we were to actually flip our coin, we would be moving into experimental probability. So this is the ratio of the number of outcomes in which a specified event occurs to the total number of trials in an actual experiment, right? So if we were to take that same coin from the previous example, theoretically, if we were to flip it 50 times, we should get 25 heads and 25 tails, right? Theoretically, because it's a 50-50 chance. But if we were to actually flip our coins, this might be a possible outcome we would get, right? Because we don't always have to follow the exact probability. So if we were to flip it 50 times, we may get 26 heads and 24 tails. So then to figure out our ratio, if we wanted to discuss our answers, we're just going to do the number of times the event occurs and the total number of trials. So again, if I wanted tails, I'm going to pick 24 tails. That's how many times it happened out of the 50 times I flipped my coin. All right, so that's the big difference between theoretical and experimental, right? You have your theoretical, then you go and you do your experiment, and that will give you your experimental data. All right, so now let's go ahead and finish up with our last set of vocab. And we have simple and compound events. So simple events are events where one experiment happens at a time and it has a single outcome. Or in other words, one thing is happening at a time. So like flipping a coin, right? One thing's happening, heads or tails, we're flipping a coin. We're doing one single event. A compound event is an event in math that involves finding the probability of more than one event occurring at the same time. So a compound event, which we're going to focus on a little bit more today, is if I were to flip my coin and then roll a dice, right? If I were to roll a die that had 6 sides, right? I'm doing two things. So I have one experiment happening and then I have a second thing, but I want to know what's the probability of them both happening combined. So that's a compound event. And to help with compound events, it's very helpful to draw tables and diagrams, right? Because they're very helpful to list out all of our options. That way it's easier to find out what our theoretical probability is. Because sometimes there's a lot of stuff going on, so it's easier for us to write it out and understand the diagram, and we can make our proportions from there, all right? Ms. Master, why are you talking so much? You're right, all right? So let's just get to work, and let's look at our first example. So it says, for lunch, David is making a sandwich. He can choose from white, French, or rye bread, either American or Swiss cheese, and the choice of turkey, ham, or pastrami as a meat. Represent the combinations of bread, cheese, and meat David could make for his sandwich. Now, this is a long example, so if you need to pause the video, go ahead and hit that button so you can copy it down, and then you can follow along with me. All right, so we want to know all the possible options, and so we're going to do this. I'm going to color code it as we go along. And when you make a sandwich, you got to start out with your bread. So David has white, French, and rye. So I'm going to write that first. So we're going to do white, French, and rye. All right, now that he has his bread, let's go ahead and put some cheese on it. So we have American and we have Swiss. So if he picked white bread, he can choose American or Swiss. If he picked French bread, he can pick American or Swiss. And if he picked rye, he can pick American or Swiss. So I'm just going to write that in. He can get American or Swiss, American or Swiss, American or Swiss. All right, now that he has his cheese, we can put some meat on it. So he has turkey, ham, and pastrami. So now we have to list those options for each of our cheeses, right? Because he can do white bread, American cheese, turkey, white bread, American cheese, ham, white bread, American cheese, pastrami. So for here, he can do turkey, ham, pastrami. For the next one, he can do turkey, ham, pastrami, turkey, ham, pastrami, turkey, ham, pastrami, turkey, ham, pastrami, and turkey, ham, pastrami. All right, so if I were to write those, I'm just going to use T, H, P, T, H, P, T, H, P, aka turkey, ham, pastrami, turkey, ham, pastrami, turkey, ham, pastrami. All right, so we have just listed out all the combinations. So this is what the answer would be to turn in. Now let's say they wanted to know what's the total number of outcomes, right? We listed it. Now you want to know what's the total number of sandwiches that David can make. To do that, we're just going to multiply each option together, right? So what that looks like is for bread, he had 3 options, times for his cheeses, he had 2 options for cheeses, times his 3 options for meat, right? He had white, French, rye, American, and Swiss, and then he had 3 choices of meat. So if we were to multiply these all together, all right, 3 times 2 times 3. 3 times 2 is 6 times 3 equals 18, right? So he has a total number of 18 combinations that he can make, right? And another way that you can do this is you can either do the multiplication of each individual event, each individual option, or you can just count it. If we were to come here and we were to count this ending tree, you'd have 18. All right, I don't want to block up the screen too much by writing it, but if you were to count all of our green options here, you'd get 18 total options. Right? So if we wanted to know our total combos, which is weird because it's like you could need it for the next problem. So for example 2, it says Alana tossed a coin and spun the spinner. How many different outcomes can Alana get? So let's look at each event separately. So if you wanted to do a coin, you can get heads or tails. And if you were to spin the spinner, right, we have 1, 2, 3, and 4 options. So you can get red, yellow, blue, and green. Right? You have your 4 options. So let's see what that would look like combined, or what they would look like all together. All right, so if you have a coin, we want to list all our options. We have heads and we have tails. From heads and tails, we have our 4 options for our spinner. 1, 2, 3, 4. 1, 2, 3, 4. And from here we have red, yellow, blue, green, red, yellow, blue, green. All right. Now can we stop there? Oh, no, we cannot, because our question asks us how many different outcomes. So it's helpful to draw the diagram, but we got to make sure we're answering our question. So we can do our multiplication like we did the first time. So for here we have 2 different outcomes if we were to do our coin, heads and tails. And we have 4 options if we were to spin our spinner. 2 times 4 equals 8. So for here we have 8 outcomes that Alana can get in this experiment. All right. What we could also do, and I'll erase some of this so we can see it a little bit better, is we can count our options, right? We can come here and we have 1, 2, 3, 4, 5, 6, 7, and 8. So that's another way that you can check your answers is by counting. Once you've listed everything out, that last row, count them up to see your total number of outcomes. All right, so Alana, if you were to do this, you have 8 different combinations that you could get. All right, let's go ahead and move on to our last example. I'll read it to you because it looks a little small. So it says Bailey will roll a number cube and flip a coin for a probability experiment. The faces of the number cube are labeled 1 to 6, or like a regular die, and the coin can land on heads or tails. If Bailey rolls the number of coins once and flips the coin once, which list contains only the outcomes in which the number cube lands on a number greater than 4? All right, So if we're looking here, we got flipping a coin, and we have, rolling a cube and flipping a coin. All right, let's do the cube first. And they already told us that we're going to roll our cube. We can get 1, 2, 3, 4, 5, or 6 as our options, right? We have 6 sides. Then from there, we're going to flip our coin, which we know we can get heads or tails, heads or tails, heads or tails, heads and tails, heads and tails, and, oh yeah, heads and tails. All right, so now let's go ahead and write that in. So HT, 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 and HT. All right, so now we've listed all of it. So let's go ahead and see what our options are. So if we're looking here, A doesn't look right, B doesn't look right. Ooh, C looks good. Locked and loaded, ready to go. Skirt! Hold up. Hold up, hold up, hold up. That's not right. Let's pause, right? Because this is an error that I think a lot of y'all might make. So let's go ahead, before we pick an answer, let's reread and understand what our question's asking us. So we want to know which list contains only the outcomes in which the number cube lands on something greater than 4. So we don't want everything. We can list out everything, but the question only wants numbers greater than 4. Not greater than or equal to, but greater than 4. So we only want these numbers right here. We only want this set of our probability, which is our 5 and our 6 with heads and tails, heads and tails. So if we look at it, C is not right because it has everything listed. D is not right because it has 4, 5, and 6, right? And we want greater than 4, so not equal to. B only lists one option, one option for each. And so our answer is actually going to be A, because it lists both of our outcomes for rolling a 5 and flipping our coin, rolling a 6 and flipping our coin. All right, so I want y'all to be very careful when you read your problems to make sure you don't get confused. All right, so that's our last example. I hope y'all copied it down and followed along with me. And for practice today, we're going to try something new. All right, so for today, I have linked a worksheet to our post, and I want you to work it out on a piece of paper and work it out by hand. And then I want you to take a picture of your work and upload that to turn it in, right? That's how you're going to turn it into Google Classroom. Is when you go to submit your assignment, you're going to attach the photo, hit submit, and then you're good to go. If you do not know how to upload a picture to Google Classroom, I've included 2 videos, one to do if you're uploading from a phone and one to do if you're uploading from a computer, right? So please, please, please watch the video before you submit your work, right? That way you understand it, it's asking all your questions. If by using the video it still doesn't work, message me, let me know, and we'll figure something out. But this is how I want y'all to do your work for today. That way I can see y'all making your graphs and your tables, all right? So go ahead, have a great day. Have a happy Monday, and I'll see you soon. Bye-bye.